Hello student, today I will tell you about solution. In this video I will tell you what is meant by solution, then classification of solution on the basis of physical state of the solute and the solvent, and then thermodynamic condition which favor solution formation, and then the application of Le-Chatelier principle in the solubility of gas and solid in liquid. So to know all these things, stay tuned with me till the end of this video, and if you get benefited from this video, don't forget to like my video, share my video, and please do subscribe my channel. Let's start with our topic, solution. So we should know the definition of solution. A solution is a homogeneous mixture of two or more substances whose composition can be varied within a certain limit. A solution is a homogeneous mixture of two or more substances whose composition can be varied within a certain limit. Why you have to mention within a certain limit? Because suppose you are preparing a sugar solution by dissolving sugar in 1 liter water. You can dissolve 10 grams sugar, you can dissolve 100 grams sugar, 200 grams sugar, or say 300 grams sugar. After some time, you cannot dissolve any more sugar. That means you can prepare the solution to a certain concentration limit. So you have to mention it in the statement. Now, in a solution, you have two or more substances. The substance which is present in a large excess is called solvent. The substance which is present in a large excess is called solvent, and the other substances which are present in a lower concentration are called solutes. The solvent is usually denoted by component A and the solute is denoted by component B. The solvent is also denoted by component 1 and the solute is denoted by component 2. So in our discussion, whether I write A, it means solvent, whether I write 1, it means solvent, or B or 2 means solute. Now if there are two components, the solution is called binary solution. If there are three components, the solution is called ternary solution. If four component, the solution is called quaternary solution. Okay. So next move on to the classification of solution. The classification of solution on the basis of physical state of the solute and the solvent. And before going into that, let me tell you, the physical state of the solvent determines the physical state of the solution. That means if the solvent is liquid, the solution will be liquid. If the solvent is gas, the solution will be gas. If the solvent is solid, the solution will be solid. So I am putting the solution chart from NCERT book so that you can check from there only. So you can see the second column, it is written solute, and the third column it is written solvent, and some examples are given. So you can see in the first three cases, the solvent is gas and the solute is gas in gas, liquid in gas, solid in gas. Gas in gas, the very well known example is the mixture of oxygen, nitrogen, carbon dioxide, that is air. Liquid in gas, it is chloroform mixed with nitrogen gas. Then solid in gas, camphor or naphthalene in nitrogen gas. Then come to the second part where the solvent is liquid. Liquid in liquid, gas in liquid, liquid in liquid, and solid in liquid. Gas in liquid, the common example, oxygen dissolved in liquid or oxygen dissolved in water, which support aquatic life. Carbon dioxide present in cold drinks bottle. Liquid in liquid, solution of ethanol and water. Solid in liquid, solution of sugar in water, salt in water. Then come to our third part where the solvent is solid and the solute are gas, liquid, solid. Now gas in solid, it's solution of hydrogen in palladium. This is the only example we have where gas is dissolved in solid. This process is called occlusion. Occlusion of hydrogen gas in palladium, that means incorporation of hydrogen gas into the cavity of palladium so that it forms a homogeneous mixture. It does not form with other metal like nickel or platinum. Palladium is the most suitable metal for this. Now liquid in solid, liquid, mercury is a liquid, sodium is a solid. So when they mix together you get a solid solution and we call it sodium amalgam. Zinc and mercury, it is zinc amalgam. So like that. Solid in solid, copper dissolved in gold, or you have copper and zinc to give brass. All alloy are solid in solid. Next, move on to the factor influencing solution formation. Factor influencing solution formation. The first factor is the entropy factor. Entropy factor. Suppose you have two containers. Container A contain component A, container B contain component B, and after mixing you will get the solution where you have both A and B. So after mixing you get a system which has more disorderness or more randomness, or you can say more entropy. So a solution formation is always governed by increase in entropy of the system. So whenever two substances are mixed together, the total randomness of the system increases or entropy of the system increases. Hence, solution formation is thermodynamically or entropically favorable. Now come to the second point, the energy factor. Now please write down the important point in energy factor. Energy factor means the intermolecular forces of attraction. In case of component A, there is intermolecular force between component A and A. In case of B, there is interaction between B and B, and after solution formation, there is interaction between AB. So what we can say, the relative strength of intermolecular forces of attraction in the solvent and in the solute and in between the solvent and the solute will decide whether a system will give completely soluble or completely miscible, partially miscible or immiscible. So you have to consider AA attraction, BB attraction, and in the solution it is AB attraction. So you will have 2 AB attraction. So the energy difference 2 EAB minus EAA plus EBB, this difference will decide whether the solution, whether the two components will be completely miscible or partially miscible or immiscible. If the value is too large, it will be completely miscible. If the value is less, then it will be partially or immiscible. So our next point is solubility. So note down the statement of solubility. The amount of solid that can be dissolved in a given amount of solvent, usually 100 gram of solvent, at a specified temperature. So what is solubility? The amount of solid that can be dissolved in a given amount of solvent at a specified temperature. For example, if you have to prepare sugar solution, you can dissolve a specific amount at room temperature, and if you elevate the temperature say to 80 degree or 90 degree or 100 degree, you can dissolve even more amount of sugar. So solubility changes with temperature. Now the solubility of solid and gas is an equilibrium process. Solute plus solvent is a dynamic equilibrium process. When the solvent is liquid and the solute is gas, or solid. So solubility of gas or solid in liquid is a dynamic equilibrium process and hence is governed by Le-Chatelier principle. Now the first factor which influences the Le-Chatelier principle or the equilibrium condition is the temperature. The first factor is temperature. Now under temperature, again we have factor A when delta H solution is greater than 0. What does it mean, delta H solution greater than 0? That means during solution formation, heat is either released or absorbed when we mix the two components, component A and component B. So delta H solution greater than 0, that means heat is absorbed and the process is endothermic. Heat is absorbed during the formation of the solution and the process is endothermic. So for endothermic process, if you increase the temperature, then that means you are supplying heat, so the equilibrium will shift in that direction where it can absorb heat. So it will move in the forward direction. So solubility also increases. With increase in temperature, solubility increases. For example, NH4Cl, silver nitrate, sodium nitrate, etc. So all this compound, the solubility increases with increase in temperature. So B is delta H solution is less than 0. That means it is exothermic. That is, heat is released during the formation of the solution. That means when we mix the component A and component B, then solution is formed and heat is released. So if you increase the temperature is increased, then solubility decreases. And so, in case of compound like sodium carbonate, if you increase the temperature, the solubility of sodium carbonate decreases. For example, lithium sulfate, the solubility decreases. Next, we will move on to the next factor, that is pressure factor. Pressure. Now, the solubility of solid in liquid is not influenced by pressure. That means there is no significant effect of solubility of solid in liquid with increase in pressure or decrease in pressure. But the solubility of gas increases with increase in pressure and is governed by Henry's law. So we'll move on to Henry's law and see how the solubility of gas increases or decreases with increase in pressure. So write down the definition of Henry's law. There are so many statements for Henry's law and we will go on one by one. The first statement, at a given temperature, the amount of gas that can be dissolved in a given amount of liquid is directly proportional to the pressure of the gas above the liquid. What does it mean? It means, suppose you have a liquid. Say you are filling a cold drinks bottle and there is CO2 gas pressure. So if you increase the amount of CO2 gas pressure, the concentration of CO2 in the liquid will also increase. So this is the amount of gas that can be dissolved in a given amount of liquid is directly proportional to the pressure of the gas above the liquid. So this is one form of Henry's law, and the mathematical expression M is the amount of gas is mass is directly proportional to pressure of the gas, and M is equal to Kh into P. This is one form of Henry's law. Now the most popular form of Henry's law is the second one, where the concept is almost same. Suppose you have taken a cold drinks bottle and you have consumed half of the cold drinks and you are left with half of the cold drinks and you kept it closed. Okay. Now, whenever you open a new cold drinks bottle, a fizzing sound appears. A fizzing sound appears, that means carbon dioxide gas fizzes out. Now, the moment you consume half of the cold drinks and keep the container closed, then there is empty space which does not contain any CO2. Now, this empty space will fill up with CO2 because in the second time again when you open the container, you will find again the fizzing sound. So, this empty space will be filled with CO2 and that CO2 will come from the solution. So this empty space will have a partial pressure of CO2 and this will come from the dissolved CO2. So the statement of Henry's law become, write down the statement, the partial pressure of carbon dioxide or the partial pressure of gas in the vapor phase is directly proportional to the mole fraction of the gas in the solution. The partial pressure of the gas in the vapor phase is directly proportional to the mole fraction of the gas in the solution. And so we will get a proportionality constant Kh x. Now this Kh is called the Henry's law constant. Now I will tell you how we find out the Henry's law constant. Now P is equal to Kh into x. If you can see, it's a very simple equation, y equal to mx. Y equal to mx in mathematics means it will be a straight line passing through origin. So if you plot partial pressure versus mole fraction, then we get a straight line, and from the slope of the straight line, the slope is Kh. Now it has been experimentally observed that if we do the same plot at some lower temperature, say if this is T degree Celsius and we do the experiment at T minus 10 degree, then we get a curve with lower slope value. If we increase the temperature say T plus 10 degree, then we get a curve with increased slope value. So from this experiment we can conclude that with rise in temperature the slope increases. That means if we increase the temperature, so if you increase the temperature, the Kh value increases. Now if Kh value increases, then the solubility X decreases. Now how this solubility X decreases? There is a patent question in CBSE that the aquatic life is more suitable in cold water than in hot water. You have cold water, you have hot water. Okay. Now cold water, hot water, both the water bodies, it means you are considering the water bodies, say river, ocean, during summer time and during the winter time. Now the atmospheric pressure, the air pressure is always 1 atm for both the case. Both the case, the atmospheric pressure is 1 atm. Now when the temperature is low, Kh value is also low, and so to make the pressure term 1 atm, the X has to be high. So here X is greater. Here when temperature is high, the Kh value is also high, but the external air pressure is only 1 atm, so X value decreases. That means the solubility of dissolved oxygen or the solubility of oxygen decreases during summer and it increases during winter. That is, aquatic life is more suitable in cold water than in hot water. I believe you like this video. If you have any doubt or problem, you can write in the comment section, and if you get benefited, please share this video with your friends so that they also get benefited like my video, and please do subscribe my channel. Thank you.